Hello children, today we learn about significant figures. Today we learn about significant figures. Significant figures. Okay. See, the question is, write the following number to the significant figures. Okay, I am taking an example. So you write this number to one significant figure. You write this number to one significant figure. How? You see, means the significant figures means whether it is a decimal number or an integer, just you start counting from leftmost, 1, 2, 3, 4, 5, like that. This is what one significant figure means. From here, this is the significant figure, means next number you should see. It is 5 or more than 5, add 1 to the previous number, and rest of the numbers are all zeros. If it is less than 5, then don't add anything to the previous one and put the remaining number digits as 0. So this is more than 5, means we are adding 1 to the previous number. So this is 5. So what rest of all the digits are 0. So 50 point, this is decimal now, 0, 0. Okay, so 50.000 means what? 50. That's all. After the decimal point zeros are there, it doesn't have any value. This is the value 50. Okay, so coming to B bit, that is next, it is 48598 to, you write this number to three significant figures means 1, 2, 3. This is the third significant. Okay, after this you should check. This is more than 5, so add 1 to the previous one. So what is the value? 486. Then what about these two digits? Will become zeros. Okay, so next bit, that is 6841 to one significant. Okay, one significant means this we are starting from left, this one. You should check this. Okay, so this is more than 5, add 1 to the previous one, 7. What about this digit? Put 3 zeros here, Okay, so in this way we are writing the significant figures. So these two are integers, this is the decimal number. One more decimal number I'll take, see. So that is 14.952 to three significant figures, means you write this number to three significant figures. That is the question. So whether it is decimal or not, you start the counting from left, 1, 2, 3. So this is the third one. You should check this number. This is 5, means add plus 1 to the previous one. So 1 means 10. 10 means, so carrier 1, it will come here. It means 15.0. These two will become 0, 0. After the decimal, zeros are there. It doesn't have any value. So this is the value. Answer is 15. Okay. So now one more bit I am taking. That is 0.0856 one significant figure to one significant figure. Okay, now madam, you said no, we will start the counting from left. Okay, we'll start the counting from left. From here, for here, you see, this is a 0 point, means it doesn't have value. 0.0, it doesn't have value. So this 0 doesn't have value, this 0 doesn't have value. So the value starts from which place? This digit. Okay. So significant figure, you change the given problem into a significant figure, means you start the counting where the number starts. You start the counting where the number starts. So the number starts from here. So this is a significant figure. 1, 1, 2, 3. Like that we will count. Okay. So this is the significant figure here. So 1 significant means the next place we'll check. So this is more 5 or more than 5, we add 1 to the previous number. So this is equal 0.09. What about these 2 zeros? Will become 2 zeros. So before see here in this decimal number, after any decimal number zeros are there, it doesn't have value. But before this decimal number, here 0 is, it has value. So because of that we will write 0.09, but these two are not having any value. Okay, after the number it doesn't have value, before the number it has value. Okay, because of that we write the decimal number like this. Coming to one more, so that is 0.942 to 2 significant figures. 2 significant figures means, so here 0 is there, we start the counting from here because the value starts from 9, not from 0. Okay, 1, 2, 2 significant figures over. So means this you should check. This is less than 5. What is the value? 0.940. 94 as it is you will write, and this digit will become 0. Okay, means what is the value after the number 0 is there in decimals, it doesn't have value. You will write 0.94. Before the number 0 is there, it has value. Okay, so this is the way of doing the significant figures. One more bit I will explain. That is C. 0.00973. Two significant figures. See, so the value starts from where? From this number, not from this. Okay, already I said zeros have any value. Zeros doesn't have any value. So 1, 2 means this number you should check. So 0.0097, this will become what? 0. So after the number zeros are there in decimals, those doesn't have any value. Okay, so 0.0097 is the answer. So this is the way of doing the significant figures. I think you understood. Okay, if in this numbers, so digits or numbers, whatever it is, so already the number is starting with some value, then we'll start the counting. Otherwise, if the digit is starting with 0, then don't count the zeros in the significant figures. So you check where are the numbers are starting. From there you should start the counting. Okay, then you will get the right answer. So next topic I want to explain. So just you should write the approximate degree of accuracy. So approximate degree of accuracy. Okay, this you should do the problem. Approximate degree of accuracy means just whatever the given problem, round off the problem and do the answer. That's all. So for example, I am taking 23.456 into 17.89. This is the problem. So here what I do, this is approximate value, this is not the exact value. So because of that, 23 I round off to nearest tens, 17 point something I round off to nearest tens. Okay, so 23 nearest tens is what? If it is less than 25, nearest round of number is 20. It is 25 or more than 25, nearest round of number is 30. Okay, so this is less than 25, because of this is 20 into, this is less, this is what? This is in between 10 and 20. This is in between 10 and 20, 17. 17 is in between 10 and 20. So if it is more than 15, round of number is 10. If it is less than 15, round of number is 10. So this is more than 15, no? Again 20. 20 is there, 400. So this is the value. Okay, this is the value. One more thing I want to explain. See, 18 into 9.24. 18 into 9.24. Here also we round off the numbers nearest tens. 18's nearest 10 is 20. 9.24 nearest 10 is what? 10. Because 9.24 is in between, it is between 1 and 10. 1 and 10. So nearest 10 is what? Nearest 10 is 9, 10. Okay, 10. So 200. One more bit. 0.4 into 12.62. Here you should be very careful. If you want to round off this number to nearest 10 or anything, the whole value will become 0. Okay, so because of that, so 0 into anything will become 0. No, that's not the value. You should have some value. Because of that, here 0.4 is there, here 12.62 is there. Because of that, you round off this to, to nearest tenths. Okay, nearest tenths means this place you should round off. So this is the already round off place, so 0.4 into this place I want round off means I have to check this. This is less than 5. So as it easily I write 12.60 means 12.6. So 12.6, 0.4 into 12.6. You should multiply, you'll get 126, 4s are 4 6 are 24, 4 2s are 8, 10, 4 1s are 4, 5. Okay, so how many? 1 and 2 decimals are there. 1 2, from right to left we take the decimals. 5.04 is the answer. 5.04 is the answer. This is 0.4, this is 12.6. So we round off to the nearest tens. Okay, then we got the value this, because if you want to round off this, 0 into anything will become 0. So we don't do that. It should have some value. So next one more problem I am taking. Next one more bit I am taking. See, 76.24 divided by 3.2. For this also approximate value. How? Means, so this I am round off to which number? This I round off to which one? Here this is the decimal, this is also decimal. I am rounding the decimals. Okay, this I round off to what? 76.24 is 80. 76 is nearer to 80 divided by 3.2. It is in between 1 and 10. Round of numbers are starting from tens place, hundreds place, like that. If it is below 10 number is there, just take the number. 3.2 round off to 3. Below 10 single digit numbers are there, take as it is. Okay, so 80 divided by 3. 80 divided by 3. How much value you will get? That value. Okay, 80 divided by 3. So how much you will get? That you will get. Okay. How much? 80 divided by 3. Okay, 3. C. 3 2s are 6, 20. 3 6 are 18, 20, 20, 20. So recurrent number you will get. Okay. So recurrent number you will get. So this is the thing. If it is into, it is okay. If it is division, then you will get a recurrent number. Okay. So next number. So 16.42 cube, approximate value. So 16.42 is nearest tens means what? 20. 20 whole cube. Okay. 20 whole cube will take. So 20 into 20 into 20. So 2 2s are 4, 4 2s are 8 followed. Okay. This one. These are all approximate values. So coming to one more bit. That is 2.3 into 3.37 by 4. These are all below what? 10. So below one single digit means we round off as it is. 2.3 means 2. 3.37. If it is after the decimal 5 or more than 5, we add 1 to the before number. Otherwise, we don't take. So this is 3 by 4. Okay. 6 by 4. Whatever the value you will get, that value. 6 means 6 by 4. 4 ones are 4. Okay. How much? What is the remainder? 2. So 2 means 0. 4 ones are 4. Then 1 point. Okay. 1 point, we take the 0 means 5. So 4 5s are 20. So 1.5. Okay. This is the value. Okay. Next, if we take a problem like this, 0.8 into 0.95, then what is the value? Approximate value. 0.8 means it is nearest to 1. Round off. If you round off, this is up after the decimal. This decimal number is more than 5. Add. This is 1 into. This is also 1. Is 1. Okay. Coming to another problem. 0.184 into 475. Then what to do? So here 0.184. So just they are asking, give the answer to an appropriate degree of accuracy. This is the question. Appropriate degree of accuracy. Then they are not asking this number you round off, that number, that decimal. They are not asking anything. That time the question is like this. Then what to do?